Hello, viewers. In today's class, we are going to discuss one very important conceptual problem from limits, right? And here we have to discuss this limit, that is, the limit x tends to 0, and we have here a greatest integer of x square divided by x square, right? So here we'll discuss this limit and we'll see whether this limit exists or not, right? So once we are able to decide that this limit exists or not, we can solve different kinds of problems related to these type of limits, right? So let us start. Now see, here we are given that x tends to 0, right? So here we'll first find out the right hand limit and then the left hand limit. And we'll see whether the right hand limit exists or not, and similarly the left hand limit exists or not, right? So here x tends to 0. So here we have the point x is equal to 0, right? So let us first find out the right hand limit. So we'll denote the right hand limit by RHL, and we have limit x tends to 0 positive. So this positive sign indicates that we are approaching towards x is equal to 0 from the right of x is equal to 0, right? And here we'll write our function, that is greatest integer of x square divided by x square, right? Okay, now what we will do, here we'll put x is equal to 0 plus h, right? Where h is a positive quantity, h is positive, and h lies between 0 and 1. And always remember that h is a very, very, very small quantity, right? And here, when x tends to 0, obviously h tends to 0, right? So it means we are taking a point which is in the neighborhood of x is equal to 0, but towards the right of x is equal to 0, right? So this point is our 0 plus h, right? Okay, so now let us write this limit in terms of h, right? So we have x is equal to 0 plus h, which can be written as simply h. So we'll replace x by h, right? So we have limit h tends to 0, and here we have greatest integer of x square. So x is 0 plus h, which is simply h. So we have h square here, right? And here also we have h square, right? Okay, now see here there is an important concept, right? See, we cannot directly substitute h is equal to 0 in this function, right? Okay, so what we will do, see, h is a very, very small quantity, right? So h, it lies between 0 and 1. So obviously the square of h, it also lies between 0 and 1. And we have just said that h is a positive quantity, and h lies between 0 and 1. So its square, h square, also lies between 0 and 1. So by the definition of greatest integer function, the greatest integer of h square must be equal to 0, right? So now here what we will do, will write limit h tends to 0, and here this quantity is 0, right? So the entire limits becomes 0, right? So the right hand limit of this function when x approaches to 0 is 0, right? Okay, now let us find out the left hand limit, right? So for left hand limit, what we will do, we'll take LHL, and here we will write limit x tends to 0 minus. This negative sign shows that we are now approaching towards x is equal to 0 from the left of x is equal to 0, right? And here we'll write greatest integer of x square divided by x square, right? Okay, now see, when we are towards the left of x is equal to 0, so we are somewhere here, right, in the neighborhood of x is equal to 0. So this point is 0 minus h, right? So we'll take here x is equal to 0 minus h, which is simply minus h, right? And these conditions will remains the same, and when x tends to 0, then h tends to 0, and now the left hand limit is equal to limit h tends to 0, and now we can write greatest integer of uh, x square. So when we take x is equal to minus h, here we have minus h square, right? And in the denominator we have minus h square, right? So we can simplify it. So limit h tends to 0, and the square of minus h is positive h square, and here we have the positive h square, right? And we have arrived at the same limit, right? So again, by same explanation, we can see that h lies between 0 and 1, and h square also lies between 0 and 1, so the greatest integer of h square is 0. So here this limit again reduces to 0, right? So we see that the right hand limit and the left hand limit both exist here and finite, right? So the right hand limit is equal to the left hand limit, and both the limits are equal to 0, right? So we can now claim that this limit exists when x tends to 0, right? So therefore, here we have seen that the right hand limit is 0 and the left hand limit is also 0. So the limit x tends to 0 of greatest integer of x square divided by x square is equal to 0, right? So we can say that the limit of this function when x tends to 0, it exists and the limit is equal to 0.